batch number 12. Our project is about Aircast Predictive model for air pollution levels using supervised machine learning. So my teammates Mohammed Tamim Ansari, Rohit and me Varadarajan. Our supervisor is Mangala Priya ma'am. Tamim will be presenting the introduction.
Myself, Mohammed Ayman Ansari. Our topic is about Aircast predictive model for air pollution, predicting the air pollution level using supervised machine learning. Uh, the study investigates the development of Aircast, a set of predictive models for air pollution level utilizing supervised machine learning techniques. Aircast leverages historical air quality data alongside environmental and factors for forecast the air pollution in the atmosphere.
Okay, so next we are going to see about the literature survey. Here, a physical method for optical characterization of pollution in industrial wastewater. So it basically determines the level of impurities that are present inside the water. So where we are extracting the data, how we learned how to extract the data and handle the data in a proper way to provide exploitative data analysis, which is nothing but EDA, through which we will be further processing using pandas and create a proper library functions. So our next literature review is meeting the technology and methodology in big data analytics scenarios. Like it basically uses Postman technique where API is being fetched using the digital method through which we will be getting the Excel form of data. Another one is agile big data analysis, which is a modern technology where they basically use pandas and seaborn to establish and determine how the data is to be presented in front of the user. Another one is deep learning classification for hyperspectral imaging 2023. So it basically teaches about how to use the machine learning algorithms such as random forest and binary search. We have used three algorithms which we will be seeing later. And another one is similar to the first literature review, the classification of river water pollution using hypervision. So here we could able to identify the diseases which are present inside the human body, through which the water levels which they intake in the body actually determines the disease levels which are present. So here Rohit will be explaining about the objectives.
Hi, I'm Rojit. My topic is Aircast predictive method for air pollution levels using supervised machine learning. The objective of my project was it is an effective of these models is evaluated using key attributes and the performance metrics accessing their accuracy and reliability predicting pollution levels. The finding demonstrate the potential of Aircast as a valuable tool for environmental monitoring and public health planning by providing timely insights. Aircast can informally policy decisions and mitigate the adverse effects of air pollution and urban populations.
So here we will be seeing about the block diagram. So basically the block diagram refers to the, we will be extracting the data from Kaggle where we name it the database as air pollution dataset. Afterwards we will be using NumPy and Pandas for data cleaning purposes, and data visualization is mandatory. Why? Because we have to know about the data structure which are present inside the data like a CSV file, and then we will be importing XR3 classifier, which is nothing but an machine learning algorithm through which the model gets implemented and it further processes with the training set of data. Here we will be using 80% of data for training and 20% of data for testing, and the model is being built through which we could able to predict the air pollution level which are present inside the atmosphere, and we will be deploying it using a Django framework where the Python language is used for the backend purposes, which connects the website front interface with the backend, which provides an interface with where the user can easily migrate data from one place to another, and they can provide the data into this website, and they can get whatever data which they require about the air pollution levels, whether the air is being polluted or not. Afterwards we will be providing a clear website which will be run on our server, which we will be seeing soon. So these are basically how the machine learning structure works. So the methodology will be done by Tamim Ansari.
Methodology of this air pollution model to analyze YouTube data using the YouTube data API. Several key methods are employed. The search method is used to retrieve a list of videos, playlists, or channels based on a search queue, allowing analysts to filter contents by various parameters such as type and relevance. The video method provides detailed information about specific video, including meters like view count and engagement statistics.
So the our components and the software components, this is nothing but a basic system, Windows 11 laptop with 8 GB RAM and 512 storage. Basically, we need an i3 11th gen to run the process smoothly without any problem. And the next one is existing system and the proposed system. So in existing system, they does not provide us a machine learning model where it can easily predict the levels of the atmosphere through the input which are being provided. And the proposed system is basically an advanced model which can predict the premature particles which are present in the atmosphere up to 2.5 level to uh, premature particle up to 10 which are present in the atmosphere. So next we will be seeing about the module 1. So it is data pre-processing where the data is being extracted from the Kaggle and it is being pre-processed in a way where the null values and the error values which are present inside the data set is being removed and the pure form of data is being imported into the pandas library through which we will be getting an structure like tables and columns. The next one is data visualization. As I said before, we will be using Seaborn for data visualization. It is an important skill which is applied in statistics and machine learning. Statistics does indeed focus on quantitative descriptions and estimations of data. So we can estimate the data which are present inside the data set. So the next one is Bernoulli-Neves Bayes. It is a machine learning algorithm which is basically used for classify a particular used for binary or Boolean features. It is based on Bayes' theorem and the algorithm is commonly used for text classification problems where the presence of or absence of the specific words can be used as features. Another one is XR tree classifier, which is considered to be the topmost machine learning algorithm which is been in current trend. The XR tree is just follows a random tree classifiers where it is being split into tree structures and the data will be accepted and removed depending upon the user. Another one is the final one is XGBoost. In order to boost the machine learning system, we will be using XGBoost. So we will be seeing the output similar to this. Okay, next we can go with the output. So here we could able to see a lot of modules which are present here, and okay, and we could say the module 1, which is basically so here we are seeing the data pre-processing and data cleaning. You see we have imported the file using air.csv, which is the file which is present inside the kaggle.com, and the dataset is being split into rows and columns. So we could be able to classify the data like PM 2.5, PM 10, NO, NO2, etc. So using the tail function we will be getting the last 5 values and head function for the first 5 values, and we are putting it into a bucket so that it could be easier for us to process it further. And next we will be looking at the exact output. So here you could able to see we usually give like runs manage py.run server, through which we will be generating a links like this. So if we go forward to this link, so here we could able to see our landing page. This is the landing page which we have been built using HTML, CSS, JavaScript. So here we will be giving the sign in option. So we have provided the default values and we will be entering it into it. Here we could able to see this is our actual page. So we describe about the air quality types: good, satisfactory, moderate, poor, very poor, and severe. So basically the algorithm which we have used, like which we are provided it into our website. You can take a reference of it, and this this is the basic report which is being used for processing the data in our website. So if you wanna take it to a sample data, you want to do a sample like thing, you just go into model and enter default values. It's just a demo video, so I will be giving some default values through like this one. So let's enter the values. CVC. Okay. This is the output which we have got for the default values which we have imported. So here we could able to see a satisfactory level of 101 to 150 air quality index is being present in the data which we have been provided. So it seems like a satisfactory kind of air quality. So basically we could able to see some minor risk of aggregation and respiratory conditions which are being present with the data which we have given. Thank you.